So we want to find out how many atoms are in 2 moles of sodium. Well, doing these kinds of molar conversions, there's a 4-step process, or really 5 steps on how to solve. First, we're going to identify the conversion relationship. Um, Find out what are we starting with, what do we end up with, we're converting between what and what. Then we're going to set up the problem, taking a given quantity, making it a fraction. Then we're going to set up the conversion fraction and use that to actually do the conversion. And then finally, we are going to just do some math and multiply it out and then solve. Very simple. So first, step 1, identifying the conversion relationship. So how many atoms are in 2 moles of sodium? My units are atoms and moles, and it looks like I'm starting with moles, and I want to convert from moles to atoms, converting from moles to atoms. Now, I know that 1 mole equals 6.022 times 10 to the 23rd atoms. As we recall, this is Avogadro's number, 6.022 times 10 to the 23rd, and that is equivalent to 1 mole. So this is the relationship that we're going to use. Step 1, we identified the relationship. Great. Now step 2, we want to set up this problem. We're going to take the given quantity, which is 2 moles, and make it a fraction. So I'm going to say 2 moles of sodium. I'm going to put it over 1. This is the setup. It gives me a numerator and a denominator. It puts moles in the numerator. There is a reason why. It sets us up for the 3rd step, which is to set up the conversion fraction. So that means I'm going to set up the conversion fraction. This is my 2nd fraction that I'm setting up. And I'm going to use the conversion relationship in order to do that. So the relationship is 1 mole equals 6.022 times 10 to the 23rd atoms. Now, I have 1 mole over here, and I have 6.022 times 10 to the 23rd atoms here. One of these is going to go on top, and one of these is going to go on the bottom. What goes where? Well, if I have moles in the numerator on this side, it's on top. I want it to cancel out. The only way to make it cancel is if I take this 1 mole and I put it down here on the bottom. So I'm going to say 1 mole of sodium. There we go. If I put 1 mole down there, then I'm going to have to put 6.022 times 10 to the 23rd atoms up top. And here are the implications of that. Because moles is on the top and on the bottom, it cancels. It cancels. And now we just move on to the next step. Because we made sure that the units cancel. They do, which is great. Now the next step is to just do the math. We're going to multiply across the top and across the bottom. So we're multiplying this setup fraction by the conversion fraction. And so multiply across the top, 2 times 6.022 times 10 to the 23rd. Atoms. That's the unit that we're left with. The moles canceled out. It's no longer there. And then on the bottom, 1 times 1. And now we just finish it off. So that's going to be, and when we put it in the calculator, it's going to be equal to, let's see, 2 times, and when we put this in the calculator, we're going to put this whole thing in parentheses so that the calculator does order of operations correctly. My phone calculator, you don't need to, but you may need to, and we'll do that this way. So 2 times, open parentheses, 6.022 times 10 to the 23rd, close parentheses. That's going to give us 1 1.204 times 10 to the 24 atoms. That's our numerator. Our denominator, 1 times 1 equals 1. And that's pretty much it. Any number divided by 1 equals itself. And so that's just going to equal 1.204 times 10 to the 24 atoms. And this is our final answer. And so, just to recap, how many atoms in 2 moles of sodium? First thing we did was identify the relationship. So we realized that we were converting between moles and atoms from moles to atoms. And so we thought to ourselves, well, how many atoms in a mole? And we know that 1 mole equals 6.022 times 10 to the 23rd atoms. And then the next step, we took the given quantity over 1 times, then we set up the conversion fraction. Moles is on top, throw moles on the bottom, and then 6.022 times 10 to the 23rd, 1 on top. That way moles on top cancels moles on the bottom. And then the next step, we just multiply across. Make sure we use parentheses around our scientific notation depending on which calculator you're using. And then our final result was 1.204 times 10 to the 24.